Good morning, my intelligent students. What we have now is mathematics for grade 11. Our topic is bearing. Bearing is all about direction. All about what? Direction. Now, bearing deals with measurement. Of points. Measurement of points on the Earth's surface. On the Earth's surface. Now, this bearing we are about to do, we need to know about triangle. You know triangle because bearing, most of the drawing are just triangular shape. So we need to know triangle. We know that some angle of a triangle is 180. And other things about triangle we need to know. That's surface. Now we are going to use in this bearing. We'll have two methods of solving bearing. We'll have a sine rule and cosine rule. But the first thing I want us to treat the sine rule first. After the sine rule, then we'll treat the cosine rule. After the cosine rule, then we'll do another types of bearing. We'll have compass bearing. We'll have 3-digit bearing. After we have done that, we'll start solving bearing problems. Now, for sine rule, look at the sine rule. We'll have something like the sine rule. The sine rule states that if you see, let me assume that I have something like this. This diagram. Let me just assume that we'll have something like this. We'll have something like this. Is a triangle. This is a triangle. Let me assume that we'll have A, B, C. Now this is the side. This is small c, the side of it. This one is small a. This one is small b. Now these are the angles. Inside are the angles. So now, if I want to find, like for instance, I have sine A. Sine A is equals to the big sine angle. Then sine B is equals to the sine small angle B equals to the sine C. Sine C, sorry, this is small b. This is big B, this is a small c, this is sine big C. If the up one, the numerator is a big angle, the down will be small, that's it. But if the up is small angle, the down will be big, that's it. You have to be consistent. Now, for us to conditions for applying sine rule. First condition, one length and all angles. When one length is given, when you have one length is given, maybe one length is given, this angle is given, this angle is given, this angle is given, or the second condition, two side and an angle opposite one of the given sides. Now, for instance, if I want to show you with example, but not the real example, now for this one condition, if I want to use sine rule, like for instance, if this is the angle, you know, we are told that one length and all the angles. Like for instance, this is A, B, C. One length, maybe here is given 5 cm, then here is given 20 degrees, here is given maybe 50 degrees, then here is given, which is 110. If this is 110 degrees, 110 degrees. Now you are asked to find this BC and AC. Then I will use sine rule. That's for the first condition, one length. This is the length that is given. And all angles, these are the angles that are given. Then you know we can use this sine rule that is here. Then for the second condition, if this is the triangle, is a triangle. Let me assume this is A, B, C. Look at the condition. Two sides, an angle. Like if, for instance, this is given 5 cm, maybe 2 cm, and an angle opposite one of the given side. This angle, maybe they give you this angle, which is 50 degrees. Do you see that it's opposite one of these? Or this can be given opposite this. Now, we can use sine. If I want to use sine, I can use this to find this angle. Once I find this and this plus this minus 180, I'll get this. So that's when we'll be able to use the sine rule. Now, examples. Look at the examples. Have examples. Let's see how we use the sine rule. Examples. Number 1. QRS is a triangle. Is a triangle with QS equals to 12 meter, comma, angle RQS is equals to 30 degrees, and the angle QRS is equals to 45 degrees. We are asked to calculate the length. Calculate the length RS. Now look at solution. We are to solve this problem. I hope you are listening. We have to solve this problem. Look at it. We'll draw the diagram. We are going to draw the diagram first. First thing is for us to draw the diagram. If this is my S, Q, R, then this one is 30 degrees. This one is 45 degrees. Then we are asked to find RS. Where is RS? We are looking for this side. From here to here. That's what we are interested in. We are going to find here. For us to find this side, now, another thing that is given is QS is 12 cm. 12 meter. Where is QS? QS here is 12 meter. Now, this is 12 meters. So, what we are going to do now is I'm going to use this. I'm going to use this one for sine. This. I beg, let me get, because I'm looking for RS, I'm going to use this and this side. So, what I'm going to do now is we apply the what? The sine rule. Applying the sine rule, what I'm going to do, you remember I need this side. See, for instance, look at it. Let me state all of them. Then I know the one I will use and the one I will not use. Let me state it. You know that this is just saying sine the small s over sine the big S equals to sine small q over sine the big Q equals to the small sine R all over sine the big R. I've stated all of them like we stated before. Now I'm going to know the one I'll use. Now this is, if I want to get this angle now, for instance, this plus this minus 180, excuse me, will give me this one, which is 100 and what? 5 degrees. That's for this one. This plus this is 75. 180 minus it, which is some angle of a triangle. Now, let's state it so that I know the one I will use and the one I will not use. Now, sine S, this side is not given, the small side, which is, so that one is empty. The big angle is sine 105 equals to Q. Sine Q, the small q is that side I'm looking for, which is RS. is not given, sine q, which is the size I'm looking for. Now, all over sine, this thing BQ is 45 what? Degrees equals to sine R. Our sine R will be what? Sine R, the small r, is going to give us what? Sine R, sine Q is 30 degrees. I'm sorry. Sine Q, look at it, Q is 30 degrees. Then R, small r is 12. All over sine 30 degrees. Now, looking at these things, let's look at it very well. Sorry, this last one, sine R is now, this small side is 12 meter, and this big R is now 45 degrees, not 35 degrees. So what I'm going to do, looking at this diagram now, this thing we stated, now, do you see that I need this sine Q? Sine small q is that RS. Look at it, sine Q, this side is RS I'm looking for. So I need this one. I need this. I cannot use this one because I have unknown here and I also have unknown. So this one will go. So what I'm going to use is this sine Q, which is now that RS, which is RS all over sine 30 degree equals to 12 over sine 45 degree. Now what we are going to do, we'll cross multiply. When we'll cross multiply, what we are going to have is RS sine 45 degrees equals to 12 times sine 30 degrees. Now, I'm interested in this RS. I'll divide both sides by the coefficient of RS, which is sine 45 degrees, which will now be, I'll divide both sides, which will now be RS. When we divide both sides, I'm going to have 12 sine 30 all over sine 45 degrees. 45 degrees. So what I'm going to have now will now be RS will now be 12 times sine 30 is 1 over 2 all over sine 45 is 1 over root 2, all over 1 over root 2. So what we are going to do now is we'll have RS is going to give us this 12 times 1 over 2 divided by 1 over root 2. Now what we are going to have is 12 times 1 is 12 over 2. Then I want to change this to times. I'll get root 2 over 1, which is 2 into itself 1. 2 into this one is 6, which will now give us 6 times this will give us 6 root 2 is our final answer. Number 2 example. Look at the number 2 example. Number 2, given that the two angles of a triangle are 30 degrees each, and the longest side is 10 meter. No, 10 cm. Full stop. Calculate the length of the other size. Calculate the length of the other size. Solution. If you look at this question, it means that this triangle is isosceles triangle. Solution, let me assume that we'll have something like this. That we'll have A, B, C. Remember they told us that the two angles are 30 degrees, which is 30. Here is 30. This one is 30 degrees. Then let me assume that this is 10 cm. Now we want to get the size of the two other distance. So for us to get that one, I want to get this angle because I need it. I need this angle. For us to get this angle now, Remember that the sum angle of a triangle is 180 degrees. So I want to get this A, angle A plus 30 degrees plus 30 degrees equals to 180 degrees. Reason sum angles of a triangle. Now A plus 60 degrees equals to 180 degrees. Angle A will now be equals to 180 minus 60 degrees. Therefore, angle A is now equals to 120 degrees. So this is 120 degrees. So now let's apply that rule, the sine rule. I want to apply it in all the angles. Now what I'm going to do now is to do sine A is all over sine, okay, small, let me use small. A is all over sine, big A, the angle, equals to sine B all over sine, the big angle B, equals to sine small c all over sine big C. I hope you are following, students. So what I'm going to do, let me put the values. Sine A, small a is this 10, which is 10 all over the big A is sine 120 degrees. Then sine B, the small b, is this side. Sine B, which is sine, is not sine B, all over the big sine B is sine 30 degrees. Equals to, the other one is sine C. Look at C, nothing is giving the other small side. Sine C, all over sine the big C is 30 degrees. If you look at this thing, I need this because we are asked to find the length of the other sides. We are looking for this side and this side. The two sides will be equal because the angles are 30 degrees. Do you understand? So what I'm going to do, I'll choose one. Once I get one, that is other angle, the other side. That is for the other side. So let me just cancel this one and use this. Once I get this small big size, it means that C will also be that same answer. So now let's continue on the other side of the board. So now, my intelligent students, see what we are going to do. I'll say I'm using 10 over sine 120 degrees equals to that B sine B, that small size I'm looking for, which I can call B. Let me call it B size. I'm looking for B, which is equals to sine 30 degrees. Now I'll cross multiply. When I cross multiply, I'll have B sine 120 degrees equals to 10 sine 30 degrees. Now the next thing I'm going to do now is to divide both sides by the coefficient of B, which is B will now be equals to 10 sine 30 degrees equals to sine 120 degrees, which is B is now equals to 10 times sine 30 degrees is 1 over 2, which is 1 over 2. All over this sine 120 is the same thing as sine 60 degrees. When you say 180 minus 120 will give us 60, because if you look at the figure table, you don't have 120 degrees there. So now B is going to be 10 times 1 over 2. Sine this thing, 60 degrees is root 3 over 2. Root 3 over 2. Now what I'm going to do now, I'll say B is now equals to 10 times 1 over 2 divided by root 3 over 2. Now this thing is sent as B is now equals to 10 times this. When I give it 10 over 2 times, I'll get the reciprocal of the other side. Once I change division to multiplication, all over root 3. Now 2 will cancel 2. We are left with B will now be equals to 10 all over root 3. Now I'm going to rationalize this thing, because when we are solving mass, when the denominator is in root, you rationalize it so that the denominator cannot be in root. So B will now be equals to 10 over root 3 times root 3 over root 3, which will now be equals to, continue here, B will now be 10 root 3 over 3. So this is our final answer. Number 3 examples. Look at it. In an acute angle. In an acute angle triangle. PQR with PQ equals to 10 cm, PR equals to 15 cm, triangle or angle PRQ is equals to 40 degrees. Evaluate angle PQR. Solution. We'll draw a triangle. Now this is PQR. This one is 10 cm. This one is 15 cm. This one is 40 degrees. Now, using the sine rule, if you want to use the sine rule, which is, if I want to use, let me say sine P all over sine PP equals to sine small q all over sine big Q equals to sine small r, the side, all over sine big R. Now look at this P, small p, this small p, nothing is here. The big P, the small p, nothing is there. Then also the big one, okay, the big P, nothing is there. Small p, nothing is there. So this one is empty. So we are not going to use that one. So sine Q, the Q is 15, which is 15 all over. Then the big Q is what? Big Q, nothing is there, which is sine Q. That's what we are asked to find. Equals to sine R, the small r is 10 cm, all over the big R, which is 40 degrees. Now, what we are going to do, we'll cross multiply. This one is what we are asked to find. We say 15 all over sine Q, which is equals to 10. Okay, let's cross multiply. When we cross multiply, what we are going to have is 10 sine Q equals to 15 sine 40. If you go to a four-figure table, sine 40 is, look at sine 40. But let me divide both sides now by this the coefficient of sine Q, which is sine Q will now be equals to 15 sine 40 all over 10. So what we are going to do, if I divide, now sine Q will now be equals to, if I say 15 divided will now give me 1.5 sine 40. Now 1.5 sine 40 is 0. From the table 6428. 6428. That's it. So when we multiply 1.5 times this will give us 0.9642. Now sine Q. Now there's something I'm going to do. I'm looking for Q. Q will now be equals to the sine inverse. Sine inverse of 0.9642. When you get the sine inverse of that 0.9642 from the four-figure table, you are going to get 74.62 degrees. Or to the nearest, this thing, one number, is going to be 75 degrees. So that's the answer. Now look at the assignment. I have two assignments for you. In the diagram, find B. We are looking for this B. In the second question, we are looking for R. Thank you for listening. Remain blessed.